Day 3. So today we'll discuss about DevOps jobs profiles and their responsibilities and their category of the role and where they work in software industry. Whenever you're finding, you're searching, doing job hunting, so you'll able to see some roles: DevOps engineer, cloud engineer. Like this, we have different roles. First of all, how an application will start and it is going to end in the end. I want to tell you with a diagrammatically presentation so that you will understand and more clear. First of all, if you take any application, so I'm just taking here one application. You can take it as a desktop application, web application, mobile application, or any sort of application it is. The first, it is going to be designed with some plan. There should be some plan. The first thing is plan is going to act. So in this plan, many members are going to be included, like CTOs, CEOs, and as well as architects, consultants. Many people will there in the plan section, and they'll plan one product, nothing but an application only. They plan one service, and they'll develop with an applications. Once the planning stage is done, and they'll give the architecture planning to the developers. Here, devs will be involved. Sorry, dev. Devs will be involved after
Yeah,
planning.
sorry for the interruption. Your screen is not visible to us.
Push. Is it visible now?
Yeah, no, it's fine.
Okay. After plan, the plan is going to given to the developers, and developers again they'll execute the architecture plan. How to they develop the application for application development. So what are the services and what programming language they have to use, and then after in which way they can write the code, functionalities, business logic. So everything they are going to decide with their plan, and they will be going to work on the development. So I'll going to take in this one box. So entire development team will be work on the code. So they did some code, for example. Where they're going to keep this code? Are they going to keep this code in their drive? Are they going to keep this code in their mobile or in their laptop? No. It is not recommended to keep the code in their drive or laptop or somewhere. So it is a company important asset. So we will be going to keep this into a source code. Okay. So that is nothing but GitHub or GitLab. GitHub or a GitLab or Bitbucket. So here we going to keep, because it is a source code management tool. For this application, program is a source, right? And there is a code, and we have to manage it. We have to maintain the versioning. Today one development team done some changes. Tomorrow also they have done some changes, and day after tomorrow also they have done some changes. So each change we need to track. Each change we need to track. So to track is going to possible with the source code management tool, and it provides high security for your programming code. So that's why every company will trust in the GitHub, and GitLab will keep our source code. If you take Google also, they have source coded GitHub only. If you take Amazon also, they have the source coded GitLab and GitHub only. that big companies are trusting this. So there's a trust is there between the companies. And GitLab and GitHub also most trusted tools for your source code management. So once the code is pushed here, and then this code, we are going to do some build process. Okay. So this build process is going to happen through your Jenkins or any CI/CD tools. You can also utilize GitHub itself with the GitHub Actions. To make you understand, I'm taking here Jenkins. For what? For only CI purpose. What is CI purpose? Continuous integration. What does mean by continuous integration? Means whenever the code is developed, the code is pushed into the GitHub. So developer already did his test and check runs in the laptop. That is the primary check the developer is doing. Then after, the code is moved to the source code, and from here we'll move to the Jenkins. Now Jenkins tool is going to take this code and it will do compilation process, and it will compile the code and it will generate the bytecode and it will convert into a package, generate the package. That package we are going to be deployed. So this process is going to done here in the Jenkins along with your build tools. Along with your build tools. Okay. And once this process done, whatever the package you have generated, so that package you can keep it in somewhere, where as a backup into JFrog or Nexus. You might heard these tools, JFrog and Nexus. So here we are going to keep this package. Here we're going to keep this package. Whatever the package is generated, so here we're going to keep here as a backup. Now while this build process going on, so I want to test out. I need to do static analysis on the code. Is it the right code? Is it the wrong code? Okay. So I need to do some analysis on the code. So to do analysis, we are going to integrate with this SonarQube or Veracode. Okay. And dependency check and other we can do integrate some sec tools also here, so that it is going to do a scanning on your code. Is it a perfect code or not? Is it in the standard way or not? So you can find bugs, vulnerabilities, whatever things happen through the SonarQube. So like this, we will be going to be integrate these tools. And if you want to do continuous testing and you want to integrate a Selenium, so here you can integrate Selenium from here itself with one pipeline. Okay. Selenium, and it is going to do a continuous testing here. It is going to do continuous testing. We call it as CD. And once this package is generated and these things are done and checks passed, the same thing is going to be second phase into different environments. Now I'm taking this environment. For example, so this is the dev environment and this is the UAT environment. And this is the prod environment. This is the prod environment. Okay. This code, whatever the package you have generated here, so this is going to be deployed into this environment. So in this environment, what will be there? Again, servers only. servers only. You're going to keep servers here, not single server. You're going to keep multiple servers for deployment. Here. Now you are connecting to this environment, and you are connecting to this environment, and you are connecting to this environment. So this package is go and deploy here. A copy of the package is it is going to deploy. Okay. It go and deploy here. So when it is go and deploy here, you will be having for a separate URL for your development environment. For an example, if you are having ABC is the DNS, so we take www.dev.abc.com for internal checks, and it is same like uat.com, user acceptance test, and here it is directly a main DNS where my application is live on the production. So like this environment will be. This package, when we are going to deploy into the dev environment, when developers done some code and they have built it the package and they have kept it to the repositories as they're treating it as an artifact for backup, and the same thing we are going to be keeping the deploying into the dev environment because our testing and analysis everything is happen. Now I want to check, or a developer want to check, is it working as expectedly? Yes, if it is working as expectedly, then we are going to deploy into UAT. So once UAT has been done, then testers will come into the picture and they'll tear down everything, application services, functionalities, everything, and they'll write the report, they do their load testing and something and all. And if it is satisfied, then we will plan to move to the production. And that's how we're able to access. This is how this application is going to work at the production. Now, once it is deployed, we are going to integrate some monitoring system for entire structure. So this entire structure is going to be enclosed in cloud platform. Now we are going to keep this in cloud only completely. GitHub is not in the cloud. We are going to keep in the cloud only. And here I'm going to integrate some monitoring system like Grafana and Prometheus. So what we will do, we are going to connect this application. We're going to connect this application to this monitoring, and we are going to connect this entire environments also. Entire environments also. Production, this one. So this monitoring tool, you can take Grafana, RealK, or you can take App Dynamics, Datadog. These are all the tools there. Now with this monitoring tool, what you're going to monitor? You're going to monitor about the servers which are there in the environments, about your infrastructure, and also you are monitoring the application status, the service status, everything, the error handling, whatever happening here in this application inside the service, everything you're going to be monitor through your monitoring tools. Okay, so this is how the structure, how the software development life cycle, a application is going to work in software development life cycle flow, where the DevOps is playing a key role with this workflow. Now, whenever you entering into any organization, you can imagine this image that the same workflow you will be able to see. But here, I called here CI And after this, I'll draw a line here. After this, I'm going to call it as CD, continuous delivery. After this, continue. So here I'm going to call it as CM, continuous monitoring. Okay, here I'm going to call it as again CD, continuous development. So whenever you search the definition for the DevOps, continuous development, continuous integration, continuous testing, continuous delivery, and continuous monitoring. This is DevOps. So this is how your application is going to work in your project. Means it's going to be built and deployed in the target environment here. So here in this workflow, which are what are the job profiles are going to work? We know that testers, and we know as well as developers, and we know that also support engineers are going to work, and there will be a database also. If you're maintaining inside the cloud, for the servers you need to maintain RDS databases also. I'm just taking a small block here. You are connecting your application with this. You're connecting the application with this RDS to store the user data, store the application data, to perform your application logics. Okay, so here you're going to. So this is going to maintained by the DBAs, data engineers. Again, okay, as we are a DevOps engineer, so we are going to involve in these areas. We are responsible to create the network. We are responsible to create this infrastructure. How? Through the Terraform or a cloud formation or whatever. Okay. So on the AWS, what are all the services are needed on the AWS for this infrastructure? We need to create. Sometimes this RDS will be not here. You will be having the on-premises data center. So this is the data center. On-premises data center, and you have to connect to the data center to your cloud through the VPN connectivity. So that your application on the public cloud, but your databases here, your databases on the DB, your databases on the complete private network on your on-premise. This is also one type of connectivity, which is hybrid connectivity. So it's just an overview, like a top overview only, and we'll go through the each profile and types, roles, and where they're going to work. This is applications. You see, so there is a first, you can find this job profile also in your LinkedIn or Naukri, wherever you're searching. So DevOps engineer, his roles and responsibilities is taking care about build and maintain CI/CD pipelines and automate and streamline the operations process and collaborate with the development and operation teams to improve the deployment practices and monitor the system performance, reusability, and scalability. The roles which is going to work. You can work on integrating various DevOps tools and platforms like Ansible, Docker. So where the Docker and Kubernetes will come into the picture, here they come into the picture in this environment here. Docker, Kubernetes will come here. The deployment tools. Okay, writing infrastructure as a code tools like using Terraform, and your entry level will be entry level to mid and not super. You are just an entry to mid level only when you are a DevOps engineer. So you can have a titles like junior DevOps engineer, and DevOps specialist. Okay, and the area of work, these are the categories where you can work. And there is a one more role, site reliability engineer. Site reliability engineer. Responsibilities: ensuring reliability, availability, and performance of the services. Implementing monitoring, logging, and alerting system. Here, if something has happened here, automatically it has to alert to the concerned team, which they have to look into it and solve the incident. So here we have different terms, like in a day, how many errors the users are getting, the count of error rate, what is the mean time recovery, and also if an error happen or if an error incident happen, in how much time we are solving it, the priority of the error, the priority of the incident. Some incident happened in the application, so that should be solved in just 30 minutes or a 1 hour, 2 hours, or 1 day. So we're going to be decide this level. So this level we call it as service level agreement, SLA. And to indicate this, we're going to work with SLO. Sorry, I. Service level indicators and operations, like this. We're going to define these things at the production level. So that is going to be done through the site reliability engineer only. Okay. Conduct post-incident reviews to prevent the future outages and automate routine operational tasks. The roles: balancing service reliability with the delivery speed, working closely with the development team and ensure service stability. Again, senior level: SRE, senior SRE, lead SRE. Okay. And cloud DevOps engineer. So here you are responsible for design and implement cloud infrastructure and as well as DevOps implementations. You need to work on both levels. So there are many job profiles in the market. These are all I took from the job portals only. Okay. Mid-level to senior level, and you have the job profiles like cloud DevOps engineer, senior cloud DevOps engineer, or cloud solution architect. These are profiles name, job profiles name. And DevSecOps engineer. So integrating security practices into the DevOps pipeline, conducting security assessments and vulnerability management on your code and as well as the package which you're generating through your continuous integration process, and automating security checks and ensuring compliances and audit with the industry standards. So this comes into this SecOps. You are applying security here. So here the SonarCube stage also the sec will come. In between, if you are integrating sec tools, you are integrating sec tool on the cloud, you are integrating sec tool on this process, you integrating sec tool on the delivery process, you integrating sec tool on the production, you integrating sec tool on the threat detection and incident detection, error detection at the monitoring level. Everything is come to the picture of DevSecOps when you're integrating security tools. We have many security tools. Bob Suite we have, Tryway we have, Sneak we have, okay, and CyberRock we have. We have many other tools to be integrated and check them for containerized environments also. And we can do also chaos engineering to do load testing and behavior on the cloud level and environment level. Litmus is a tool for it. You can use the Litmus to see the chaos engineering on the cloud, on the environment and behavior of the infrastructure. So these things are into the SecOps. Okay, and yeah, so band level and mid to senior level: SecOps engineer, senior DevOps SecOps engineer, and security engineer. Cyber security firms and financial institutions and government agencies mostly they use SecOps profiles, jobs they're hired. Okay, and infrastructure engineer: design and deploy, maintain IT infrastructure, server configuration, network setups, ensure infrastructure scalability and reliability. So you're going to maintain these roles, handling servers, storage, and network requirement, and you need to also coordinate with the multiple teams. And these are the levels and the profile, job profile names. And automation engineer. So automation engineer, so responsible for automate repetitive tasks and process, develop, maintain automation scripts and tools, like again for your Lambda functions or on the infrastructure on your environment. If you are a physical server data centers, you need to write some scripts to automate few things. And for your application buildings, the CI/CD pipelines. So you're going to maintain here these work roles and responsibilities. And you have automation engineer, automation specialist, and DevOps automation engineer. This is job profiles. And release manager. So plan and manage software releases, coordinate with the different teams to ensure smooth deployment, and monitor release performance, address issue. Once the code is developed and it has to deploy into the production, release manager, release team, you're part of release team. And platform engineering, we already discussed. Build and maintain development platform, ensure the platform scalable and reliable and secure. Work closely with the different teams, and you need to satisfy the infrastructure automation needs. You have to create the new implementations, design and implement the services. This is main thing. The platform and build and release engineer. Again, as I said, in some organizations, you will be build an engineer. You are going to be implement the pipeline, and after developing artifacts, you're going to be into also release management, and with your hands, you're releasing the application to production as well with the plan. So build engineer, release engineer, build and release engineer. Okay. So you can check these job profiles from where to where they are working on the different stages. You can get this document. I'll share with you. So these are the areas, and these many job profiles are there in the market where they are working. And we are going to apply our jobs, and we are going to work as we are a DevOps engineers. So these are the areas you are going to apply in the job portals. And if your resume matches, you'll get the call from all these job profiles, like how to build and release infrastructure, cloud DevOps, cloud engineer, like this. Okay. So now here, I just went with the AWS. I have Azure also, but I have this one GCP also. But why I am selecting AWS? What is the reason behind it? Why I am recommending AWS? First thing, I could start advanced DevOps with Azure also. I could start advanced DevOps with GCP also. But people are more interested on the AWS, and as well as we have more jobs on the AWS. Why? What is the demand in the market of the AWS? First thing, there will be a company called Gartner Magic. Gartner Magic. So uh, this company, what it do in the market? What are all the applications are there? Vendors are there, devices are there, server provided companies are there. Okay, it is going to analyze, and it will release a report. So who is the best and who is not best, and their advantages and disadvantages. If we check this report every year, quarterly, it will release the report. If I ask Gartner Magic Cloud Service Provider Report 2024, we'll check in the Azure website, not on the AWS website. AWS website, might they write themselves only, right? We are the top. Not, we'll check the Azure website. LTI Mindtree. It is LTI Mindtree. This is about the companies. Magic Wanted Public Cloud Service Providers Report. The links are not properly quadrant 2023. Now let me search for our. So this is GartnerMagic.com. The first one is AWS. The first one is AWS. Second one is Microsoft Azure. Third one is, and fourth one is IBM. And fifth one is Oracle, Huawei, VMware, Alibaba, DigitalOcean, Tencent, JetStack, vCloud, Lumen. Like this. This is a sequence. And if you would open, for example, Microsoft, so their ratings, and they'll write everything over here, a report. If you compare, you can see the ratings here clearly, the Gartner match. That's why the architectures, or whenever you decided to migrate, how the architectures and the technical consultants and chief technical officers, CTOs, every company will also have CTO, not CEO. CEO is separate again. CTO also there. CTOs are the key decision makers again. They're going to take the decision how. They'll do a lot of research. So this is how they do research. This is one part in the research. So their pricing, quotation, reliability, scalability, according to their project tech stack, is it perfect or not? Every aspect they'll check. And then we'll move to one cloud. And if we see a graph from the Microsoft, that's I want to show from the Microsoft itself. There is no updated images. You see in the 2023, like this, we can find 2024, where it is azure.microsoft.com. If you come, Amazon Web Service in the top. Amazon Web Service in the top in 2023. The same we have to find 2024. It's been already released. Not finding correct link. About Microsoft products they are giving. It should come in the top only. I think I'm typing something different. Cloud service providers report from Azure. From Google Cloud, let's check. It is gen.det. Google Cloud gains the cloud infrastructure magic on, but Amazon Web Service in the top. So challenges and niche players and business who are coming newly. So like this, Amazon Web Service is holding almost 50% in the market. That's how people are migrating to the AWS cloud. Learning AWS skill is the best choice for your career. And other clouds you can easily understand. And again, so let's talk something about the background and the comparison between the clouds. Okay. So first of all, what is a cloud computing? We already discussed, instead of maintaining the bare metal servers and someone is maintaining for us, that is virtually, and we are utilizing them and we are paying for it. That is the cloud computing technology. And there we are utilizing multiple services and resources. Now you can see include storage, process power, databases, networking, software, and analytics. The services we are using and we are paying to the one provider, that is cloud computing on demand. That's it. The benefits of using cloud computing: cost efficiency, it is budget friendly, scalability, flexibility, security, and disaster recovery. These are the things. And if you talk about something background with Amazon, so it started launched this cloud computing platform in 2006 and the market leader that time. And from that onwards up to now, it is the master. AWS is the master right now. Okay, and it offers wide range of services and still it is offering wide range of security. But in security aspect, I could say Azure is something good, but recently many incidents have happened at the Azure. So AWS has gained some +1 mark. Did you ever add the incident at the Amazon? No, but recent times we heard and some incidents that happen at the Azure. And the key features of the AWS is global reach and broad servicing offerings. So to the 200 plus featured service across the domains and reliability and security. And there are popular services are there. And if we talk about especially about the cloud background, the evaluation of the cloud computing happened in the 1960s. The concept of time sharing and distributed computing. And in 1990s, so the internet web-based applications are started. And in 2000s, software as a service things has introduced first through the AWS only. And in 2010, the growth of multi-cloud strategies and hybrid cloud deployments are enhanced, and that time that is under the POC, proof of concept thing, and was integrating with the multiple clouds. And by the 2020s, now we have an AI machine learning everything at the cloud platforms. And we have types of deployment model: public cloud, private cloud, hybrid cloud, multi-cloud. So public cloud services are offers through the internet and accessible by anyone. Private cloud is something you are organizing privately, securely in your private network. We discussed right, private IPs, IP ranges. With that, you're going to build a network. And multi-cloud, again connecting with the multiple clouds for your redundancy. And the comparison between the three clouds. The market share, you can see right now, this is the current statistics in 2024 on this month. This is the market share. Azure, GCP, AWS. And service offerings, also you can have a look at, like over 200 plus services AWS is having, strong in hybrid and cloud enterprise Azure, and strong in data and AI. And global presence, so widest global presence for the AWS and comparingly with the Azure also same, and few regions GCP. And pricing level pay as you go, spot instances for saving, competitive pricing especially for the Windows, something more on the Windows, and often considered more cost effective on the GCP. You have to pay something more, but one feature in the GCP is it is too much faster than the Azure and AWS. And compute powers, you can have a look at the services, and storage solutions, we know already about these things, and networking and security hybrid and developer tools and customer base. And which one is the good one and who are going to be most friendly with the cloud? So enterprise, startups and government with the AWS, and strong enterprise presence and Microsoft ties with the Azure, and with GCP innovators and data centric companies. But there is a one feature I have not added on the Azure. Azure is separately given a separate cloud to the USA government. We'll find a separate cloud for the USA government to maintain the things. Azure has given that. Okay. And which is best? AWS is best for startup. Companies are looking for the broad range of services. Those are needed, mature and reliable cloud platform extended global search. And Azure is for ideal for the enterprise, especially for already using Microsoft product that existing customers, and hybrid cloud environment. GCP is well suits for the companies focused on data analytics and machine learning and AI, and some startups also. So that's why I'm preferring AWS, and you'll also find more information and more jobs, and wherever you see, you'll be able to listen about the AWS. So this is the importance of the AWS first. And to create AWS account, so first of all, you need to search Amazon Web Service or www.aws.com. When you search this, it automatically opens your console. Okay, sign into the console. Click on this, sign into the console. So here you have to create an AWS account to do practice. Create a new AWS account. First, you have to give your root mail ID and account name. Once you verified with your security, then it will ask some information about you, your personal information. And then after, card information for the payment. Okay, payment information. So for this payment information, we can give debit card, don't give credit card. Now it is supporting Master, Visa and Rupee cards. You can use Master, Visa, Rupee cards. So when you provide your information for the payment, it will deduct 2 rupees from your account. And it will be refunded in 5 working days, but to validate your account, they're going to deduct 2 rupees from your account. Once the deduction happen, it will automatically redirect to your console and you can use 12 months free. And there is a free tier quota. Okay, free tier quota. So under free tier quota, you can use 12 months few services. not completely 1 year free. It is going to block if you are excessively using. You can create this account. It is simple. If you search in the YouTube, you might get one video, and no need of video as well. It's just you need to provide some information. It's same like your Facebook account creation. The only thing you are entering payment details. That's it. I request you all, please create. Once you have created, it will return to you like this. Click on root user, provide your email and password. Once you have provided like this, and it will prompt you to a new page. So this is AWS console. We call it as console. And we have 24 regions here. Right side you can see here. I'm in the Mumbai region. They have 24 regions. 24 data centers we can go and create our services. Okay. We'll continue this part from the next class. If you have any questions and doubts, you can ask me. I'm happy to answer. And I request you to create AWS account so that we are moving ahead, and I want to take you all through basic to advanced. So we have to go with the labs only. I'll I'll tell you means I'll teach you somewhat portion in theory, then everything I'll match with the practical. So these are the basic things which we are right now in the journey. From tomorrow onwards, we're going with the practicals.
So which topics we will cover in the AWS? Can you please provide the overview?
Yeah, sure. So we are going to cover networking like VPCs, transit gateways, and VPN connectivities, and the advanced method of connectivity in the networking itself, and building your subnets and security things, NSCLs configuration, and blocking their specific traffic controls, and VPC endpoint connectivities and network flow logs, all this. And then with the compute services, EC2 instances. So there are different types of instances, general purpose and memory and compute optimized like this. So with these instances, how at what level you can use which type of instance, and also there are on-demand and spot instances. In which case you are going to take those instances, and what are their configurations, how you deploy them, and inside the instances how you can deploy the application, and how you're going to connect with your presentation layer, business application layer, and the database also. So those things I'm going to teach you on the EC2s. And in the backup of that EC2s, AMI, snapshots, and connecting and increasing the scalability of the server like EBS, and maintaining the EBS, nothing but the volume, and providing high availability between multiple availability zones with the traffic distribution load balancers, and maintaining the reliability and high availability and scalability with the auto scaling groups and its behavior and the configuration, and as well as to make sure the user has to be a specific permissions and privileges inside the cloud. We have to go with the identity and access management, and also we need to know about the database things, RDS, and monitoring things, CloudWatch, and as well as content delivery network, CDN. And also whatever you're doing activity, you have to maintain one track record in the console. For that, we're going to maintain this CloudTrail. And for the notification purpose, SES, SNS, for queuing purpose, SQS, and auto deployments and serverless technologies, Lambda. So, and DevOps services, code pipelines, and EKS, ECS. These are the things we are going to discuss and do some projects and classes, labs on the AWS.
Okay, sir. And the next question is like what kind of projects we are gonna cover, the real-time projects?
So, as I said in the first video also, monolithic microservices, 2-tier and 3-tier projects, and it could be e-commerce, it could be something application, or it could be a web application, web-based application. So like this, different applications we are going to deploy in terms of monolithic, static, web, and microservice. Clear? Anyone having any doubt more? So who are not enrolled, please enroll so that you'll get the drive link for the recorded videos and the notes. Thank you all. We'll meet tomorrow at the same time.